The lesson topic for this video is factoring by grouping. Now, factoring by grouping is actually going to seem an awful lot like factoring using magic number because it is similar. In fact, it's actually going to seem a little bit simpler. All right, so anytime we factor, we need to remember to first look for a GCF. So 27, 45, 3, and 5, those four numerical coefficients and constants do not have a common factor. And then, although we have x's in 3 of our terms, we do not have it in our last term, so we cannot factor out an x either. So we're going to start this problem just like one of the steps in magic number, and that is we're going to just break these four terms into two groups of 2 by putting that vertical line down. And now the steps are actually very much the same as magic number. So the first thing we're going to do is find a GCF of the left-hand side. Notice that 27 and 45 are divisible by 9, and x to the third and x squared have a common factor of x squared. So we're going to factor out 9x squared. And once we do that, we're going to say, okay, 27x to the third, if we factor out 9x squared, we'll be left with 3x. And if we have 45x squared and we factor out 9x squared, we'll be left with plus 5. All right, and then the right-hand side of the vertical line, notice that 3 and 5 can't be divided out or divided by any common term, but we can divide out a -1. So we're going to factor out a -1 minus 1. Remember, always take whatever that sign is out with it, the GCF, and we're going to find out what we have left here. So if I have -3x and I factor out -1, I'm left with positive 3x. And then if I have -5 and I divide that by -1, I'm left with positive 5. And that's good because we have 3x plus 5 and 3x plus 5, so we have a common expression in our parentheses. So we're going to factor that out, 3x plus 5. And then after we factor that out of each term, we're left with 9x squared minus 1. Now remember, you're only done factoring if you have factored completely. To factor completely, you have to double check that there are no difference of squares or maybe a GCF that you have missed. So everything looks good here. This is completely factored, but look at the 9x squared minus 1. 9x squared is a perfect square because 3x times 3x is 9x squared, and 1 is a perfect square because 1 times 1 is 1, and it is a subtraction sign in between, so it is a difference of 2 squares. So what we're going to do is we're going to leave our first factor as it is, and then the 9x squared minus 1 we're going to break down into 3x, again times 3x gives us that 9x squared, and 1 times 1 gives us the 1. Put a plus here, put a minus here. Alright, so this is our final factored form for this expression. So let's go ahead and take a look at this next one. 2x to the fourth plus 14x to the third minus 16x minus 112. Again, do not immediately put a vertical line down. You don't want to do that because if you do, you're missing an important step, which is GCF. Notice that 2, 14, -16, and -112 are all divisible by the number 2. So we're going to put that 2 out front, okay, and we'll say what's left. So we'll have x to the fourth plus 7x to the third minus 8x minus 56. All right, now we've factored our GCF, and we're going to put the vertical line down in between our two sets of, our 2 terms on the left and our 2 terms on the right. Remember, when you do this, you're going to want to just bring your 2 down to where the final answer may be, so that it's not in your way during your factoring. So we're going to factor out the GCF of this, which is going to be x to the third. Factor out x to the third. And we'll be left with When we take an x to the third out of x to the fourth, we'll be left with x plus 7, because we'll take the x to the third out of there too. And then on the right-hand side of that red vertical line, we're going to factor out a negative 8. Negative 8. Okay, so always factor out the negative, and then both 8 and 56 are divisible by 8. So when we factor out the 8, we get x. And then remember, we factored this negative sign out here. We factored a negative 8 out. So then we have plus 7. Again, our parentheses match. It's a good thing. So we are now going to write x plus 7 as our GCF of our two terms. And then we have x to the third minus 8. Now, we have our final factored form here. We actually, just so you know, there is an additional way we can factor x to the third minus 8. We're not going to go into that right now, but if you are thinking that that could be factored down, it's true, but we're not going to be working on that in this unit. All right, so here are a couple more examples. If you'd like to pause the video and try them on your own and then check back to see how you did, go ahead. If you feel like you'd like to see a couple more examples worked out, let's do that. But one of the two, please. All right, so the first one, if we look at this, we do not have a common GCF factor here in the coefficients, nor do we have a C in all three. So we can just put our vertical line down and begin our factoring on each side. On the left-hand side, we can factor c squared out of that, and we're going to be left with c plus 4. And on the right-hand side, we can factor out a negative 9, and we're left with c plus 4. The c plus 4 matches in our parentheses, so we're going to go ahead and write our parentheses down, c plus 4. And if we factored that out of here and here, we're left with c squared minus 9. Again, remember that you are not done factoring until you've double-checked that you don't have any difference of squares. We do have a difference of squares right here. We're going to need to break that down. So we have c plus 4, and then we'll break this down into, well, c times c is c squared, 3 times 3 is 9, 1's a plus, and 1's a minus. There's our final factored form. And our last example off to the right, if you stopped and tried this one on your own, I hope you remembered again the GCF at the very beginning of the problem. And the GCF is an x. All right, we're going to factor out an x. We'll be left with 6x to the third minus 6x to the second minus x plus 1. We do definitely need that 1 right there. All right, so now we're going to go ahead and put our vertical line down here. And again, that means we should probably just bring that x straight down to our answer. And now we are going to factor out our GCF of the left-hand side of the vertical line. Notice we have a 6 in both, and an x squared can be factored out as well. So 6x squared is factored out. When we factor out a 6x squared, be careful here. So this, ooh, didn't mean to do that, but okay. This right here, we would factor out the 6 and x squared out of the x to the third. So we have x left. And then a minus sign. And then notice right here, we did factor out the 6 and the x squared, but you definitely need a 1 right here. If you miss that, you might have some trouble. On the right-hand side of the vertical line, we have x plus 1, and really all we need to factor out here is a negative. So negative 1 is being factored out, and that leaves us with x minus 1. Again, because if this was a plus and we factor out a negative, this is going to be negative, because negative times a negative will be that positive there. Which is good because that makes our parentheses match. And we're going to go ahead and write down x minus 1. And what's left is 6x squared minus 1. All right, so once again, we're going to double check that we have factored out everything completely, or factored everything completely. The question is like this a difference of two squares? It's a difference, This is a 1, that's a perfect square. X squared is a perfect square, but how about 6? Okay, not a perfect square, nothing times itself is 6. So this is our final factored form.